Okay, so today we are going to do areas of trapezoids, rhombuses, and kites. Today is a little bit more intense than we did yesterday just because of the trapezoids. Now, I don't think these formulas are super difficult, but what you guys will see is we're going to need to draw in a lot of super incredibly fun prior information that hopefully you haven't forgot yet to do some of these problems. So, let's talk about the formulas. So first of all, a trapezoid. As a reminder what a trapezoid is, difference between a trapezoid and a parallelogram. Yesterday we did parallelograms. A parallelogram has two sets of opposite parallel sides. A trapezoid has exactly one pair of opposite parallel sides. Okay? So the top and the bottom have to be parallel. The other two sides cannot be parallel. It cannot possibly be a parallelogram and a trapezoid. It has to be one or the other. Okay? So to find the area of a trapezoid, you're going to take 1/2 the height. Now, just like yesterday, make sure the height is, if it's sitting on the base, okay, how tall it is. Okay? So looking for that right angle again. But then what you're going to do is you're going to take the two bases and you're going to add them together. Okay? Yesterday, the bases were the same because it was a parallelogram, but with a trapezoid, they're going to be different. Okay? So you're going to add those two numbers together. Notice that's in parentheses, so you have to do the adding first. So you're going to add the bases together, take 1/2 the height times that sum. Idea is pretty simple. We'll kind of get into why this gets a little tricky here in just a minute. Now, the area of a rhombus and the area of a kite, they're both the same, which is kind of nice.
Excuse me, can you send Gabriella Graham to the main office? She's going to be leaving for an appointment.
Okay, she's on her way.
Thanks.
So the area of a rhombus and the area of a kite. Now remember, a rhombus is a parallelogram with 4 sets of congruent sides. And a kite, if you remember, is a quadrilateral that has 2 pairs of congruent adjacent sides. So these 2 sides are congruent and those 2 sides are congruent. So what you have to do to find the area of a rhombus and the area of a kite is you're looking at the diagonals of each. If you take each diagonal, multiply them together, multiply that by 1/2, that's going to be your area for both of them. Now the big thing with these ones is make sure you're taking the entire diagonal. Sometimes they'll trick you and just give you like 1/2 of the diagonal, so you're looking for the entire diagonal. Multiply together, multiply by 1/2. Those ones are pretty easy, okay? The ones that are a little challenging today are going to be the trapezoids, okay? And here's why. In order to find the area of a trapezoid, you need 3 things. You need the base, the other base, and the height. Now, if you look at this problem, I have the top base and I have the bottom base. I've got 5 and I've got 7. But I don't have the height, right? The height should be right here. So I have that right angle. But they don't tell me what it is. So I have to find the height. Here's why these can get a little challenging. What we're going to do is we're going to draw the height just in a different place. We're going to draw it right here. That would also be the height. That would be the same thing as that on the right-hand side. The reason why I want to draw it right there is because look over there on the left-hand side. What did I create? A right triangle. And specifically, I made a 30, 60, 90 triangle. Which, this is where all that super fun, amazing prior information comes from, right? Coming back to you guys, okay? A 30, 60, 90 triangle. Let's remind ourselves. If this is the 60-degree angle, and this is the 30-degree angle with the 30, 60, 90 triangle, you want the short leg. That's your S. That's what you really, really want, okay? Once you have S, the hypotenuse is easy to find. You remember how to get from the short side to the hypotenuse? It's double it, 2S. The longer leg, S square roots of 3. What I need that longer leg. I need that S square roots of 3, which means I need that S. I need that right there, which I can find, right? If the top is 5, which means that part's 5, and the whole thing's 7, what is that little chunk right there? 2, which means S is 2, which means the longer leg is 2 square roots of 3, which means the height is 2 square roots of 3. Now you have all of the information you need to find the area. So to find the area of a trapezoid, you're going to take 1/2 the height, We just found the height. It's 2 square roots of 3. And here's you have to be careful. You're going to add the bases together. You have to add them first. Okay? So the top is 5. The entire bottom is 7. So you're going to take 5 plus 7, and you get 12. So to simplify this, a lot of times today it's going to say write your answer in simplest radical form. What that means is you just want to leave the radical. You don't want to turn it into a decimal. So you can take half of 2, which is just 1. And then the best way would be to move that 12 in front of the radical. And we'll call it 12 square roots of 3 meters squared. Just like yesterday, area is always in square units. Okay, questions on that trapezoid? Okay, we're going to spend a lot of our time and energy today on trapezoids because the kites and the rhombuses are really pretty simple. Remember, with the kite and the rhombus, you're going to take each diagonal, the whole entire diagonal, multiply them together, and then take half of that. So in this one, I mean, they give me all the information to need. Now this is a kite, right? A rhombus would have all 4 sets of congruent sides, but a kite, okay, those 2 sides are congruent, those 2 sides are congruent. So I need each diagonal. So when I look at that more vertical-ish diagonal, it tells me that's 3 and that's 3, but I need the whole entire diagonal. So what would that whole vertical diagonal be? 6. So we're going to take half of 6, and then the other diagonal, remember, if that little piece is 2 and that bigger piece is 5, what's the entire diagonal? 7. So you're going to take half times 6 times 7, kind of like we talked about yesterday. You don't have to multiply in this order. Either way, you're going to get 21 meters squared. Okay, questions on either one of those? Yeah. Okay, moving to page 33, going to be section 10.2, areas of trapezoids, rhombuses, and kites. Okay, so we're going to keep the first couple pretty basic. So find the area of the trapezoid. Going to be drawing lots of trapezoids today. So remember, a trapezoid has exactly 1 pair of parallel sides. Now, in this trapezoid, we're going to call that a right angle. The top is going to be 4 meters. The left is going to be 6 meters. And the bottom is going to be 10 meters. If we're going to find the area of a trapezoid, you need 3 things. You need the top base, the bottom base, and then the height. In this case, they give me all of those. So to find the area, you're going to take 1/2 times the height. Which one of these is my height? 6. And then you're going to take both bases. You're going to add them together first. When you take 4 plus 10, you get 14. And remember, you don't have to necessarily multiply in this order. I would probably take half of 14, which is 7 times 6. Either way, you get 42 meters squared. Okay, let's try another one of those. Let's say we've got a trapezoid that looks like this. Kind of upside down-ish. I don't know why I think that, but that's what I think. Okay, so let's say the top is 12.3 centimeters. The bottom is 8.7 centimeters. And then that distance there is going to be 4.5 centimeters. Now we're going to find the area of the trapezoid. You need both bases and you need the height. Kind of like the last one. They give me all of those, so we can go ahead and plug them into our formula to find the area. You're going to take half of the height. Which one is my height? 4.5. Remember, for the height, you're really kind of looking for that right angle there. All right? And then you're going to add your bases together. So 12.3 plus 8.7 should give me 21. And when you multiply all of those together, you should get 47.25 centimeters squared. Don't forget your units. Okay, so you'll have a few, just a few, that are pretty straightforward, pretty simple. Do you have questions on those ones? Okay. Now the next one we want to do is we want to leave our answer in simplest radical form. I came up with these examples on my own, so I'll be honest with you. It says if your answer's not an integer, when you get to your homework, it'll work out better, but I did have some decimals in here, which will be fine. But it just means that if you have a radical, don't turn it to a decimal, leave it in simplest radical form. Okay? So, number 3. Okay, we're going to have a trapezoid that's going to have this angle right here is going to be a 45-degree angle. Okay, the top of this trapezoid is going to be 13 feet, and the bottom is going to be 18 feet. Okay, so remind yourselves, in order to use the formula for the area of a trapezoid, you need the height and both bases. What am I missing? Missing the height, right? So, kind of like we did on the last one, we're going to create this right triangle over there on the left. Now, the last one was a 30, 60, 90 triangle. What kind of triangle is this? A 45, 45, 90 triangle. To remember the important, awesome, incredible relationship of the 45, 45, 90 triangle.
They're cool.
They're cool. Yeah, they're very cool. Very cool. Yeah, the two legs are congruent, right? These are your S, right? And we're not going to need it in this one, but the hypotenuse is S square roots of 2. Yeah, excellent. Okay, so if I could find this, I would be able to find the height. I can find that, right? Because I know that's 13. The whole thing is 18. So what is this little chunk of a leg right there? 5, which means the height is also 5. So once you have the both bases and the height, you can plug it into your formula. So to find the area, you're going to take 1/2 times the height, so times 5, which we just found. And we have to add the bases together. So 13 plus 18 would give me 31. And then when I would multiply those together, we should get 77.5 feet squared. So get your units. All right, you guys ready for this one? You guys haven't even broken open the can of fun yet. Okay, are you ready? Okay, number 4. I know there's no sarcasm in any of your responses. Just like I don't ever use sarcasm in my lessons either. Ever. Okay. All right, let's say we're going to actually drop that down here. So put a right angle, which means that's going to be my height right there. Okay. So the top of this is going to be 6 inches. This side, this is definitely not drawn to scale. Just going to throw that out there. This side here is going to be 13 inches. And then just this little piece right here is going to be 12 inches. Okay? All right, so first thing, we have to remind ourselves, here's what I need in order to find the area of a parallelogram. I need both bases. I have the top. They don't necessarily give me the bottom, but they, can I find the bottom? Sure. Right, if that's 6, then this is 6, so the entire thing is, okay, so I do have both bases, but I need the height, kind of like the last one. Now, the last 2 that we did, it was a special right triangle. It's either a 30, 60, 90 or 45, 45, 90 triangle. Do I know for certain that this, I mean, it kind of looks like a 30, 60, 90 triangle because the way I drew it. Do I know for certain it's a 30, 60, 90 triangle? Do I know for certain it is a 45, 45, 90 triangle? No. They don't tell me any of that. Okay? So you can't use the special right triangles. You have to use, the last chapter, we learned other ways to find missing side lengths. Okay, so one way, okay, if we're, kind of thinking here, I've got some sides, we had those trig ratios. The problem with the trig ratios, you have to have an angle. I don't have an angle, right? What was the other way we worked with right triangles? Yeah, the Pythagorean theorem was the first thing we did, right? The Pythagorean theorem. If if you have two sides of a right triangle, you can find the third. What does the Pythagorean theorem say? A squared plus b squared equals c squared. These two sides, the sum of the squares of these, equals the square of this. So my height, if I were to take, let's get over here, my height squared plus 12 squared, it should give me 13 squared. Pythagorean theorem. There we go. So we'd have h squared plus 144. 13 squared gives me 169. You have to move the 144 over, and we should get h squared equals 25, which means h equals 5. And we're taking the square root, so h equals 5. So my height is 5, which means I have everything I need to find the area. So in order to find the area, you're going to take 1/2 of the height, which I just found, which is 5, times, add the two bases together. So remember, the top base was 6. We said the bottom base, the entire bottom base, was 18. So 6 plus 18 would give me 24. Multiply all that together, you should get 60 inches squared. So, you may not just be using the special right triangles, you may also get to use the Pythagorean theorem today. Yeah, I know. I'm so excited whenever I start making these friends. Okay, let's try another one. Number 5. Okay, so we'll do a trapezoid that looks something like that. We're going to do similar to the last one. Drop that height down. Draw that right angle. Now this time, I'm going to give you that the height is 15 meters. The top is 12 meters. And that left-hand side there is going to be 17 meters. Okay, now remember, to find the area of a trapezoid, you need both bases. I have the top, I have the bottom. I have part of the bottom, right? That part's 12, but do I know what the other part is? No. I also need the height. I have the height, okay? But I need to figure out how I can find that side length right there. So kind of your two options. If it's one of the special right triangles, that's usually the easier way to do it. Do I know that this is one of the special right triangles? I don't. You can't assume that. So the other option is, notice how I have two sides? Pythagorean theorem. So if I were to apply the Pythagorean theorem here, the sum of the squares of the legs, so if I take x squared plus 15 squared, okay, the two legs, square them and add them, it should equal the square of the hypotenuse. So equals 17 squared. So it'd be x squared plus 225. 17 squared gives me 289. Subtract your 225 from both sides, and you should get 64. Take the square root of both sides, so the x is 8. Remember, what x is, it's just that little chunk of the base right there. So that entire bottom base would be what? 20, right? We carried the 12 down, and then we found out that that one is 8. So to find the area, you're going to take half of the height, which they give me, the height is 15, times the sum of the bases. So we said the top base is 12. The bottom base, remember you said, was 20. So 20 plus 12 would be 32. Once again, I would probably take half of 32, which is 16. Then when you take 16 times 15, you get 240 meters squared. Okay, we're going to do one more trapezoid. I'll tell you, the trapezoids are the ones that they're the trickier ones. Not because the formula is tricky, it's just finding the information that you need. The heights and rhombuses are pretty simple. Let's do one more. Okay, number 6. Okay, last trapezoid. Now for this trapezoid, that bottom left-hand angle is going to be 60 degrees. Okay, we're going to have a little right angle there. Okay, so the top is going to be 16 feet, and that left side is going to be 10 feet. Okay, now, remember, in order to find the area of a trapezoid, I need both bases. Do I have both bases? No, I have the top one, right? 16. But I don't know, right, if I were to drop this down here. I know that this much is 16, but I need to find that one, so I don't know both bases. But I also need the height. Do I have the height? No. Okay, so we've got to find both of those. But what's nice about this one, what kind of triangle is that? 30, 60, 90. So remember, you're writing this in terms of S, okay? You want to find the shorter side. What I have is the hypotenuse, which is actually kind of nice. Because what's the relationship between the hypotenuse and the shorter leg? This is twice. That's double that. So what is my shorter leg? 5. Now I know that bottom base, right? 5 plus 16. What's the height? 5 square roots of 3. Excellent. Okay, and then we're just plugging these into our formula. So we're going to take half of the height, so half of 5 square roots of 3, times, okay, let's add our bases together. So my top base is 16, my bottom base is 21. 16 plus 5, so 21 plus 16 would give me 37. This is one of the ones that I talked about how it's in simplest radical form, so this is not typically an acceptable answer because we're going to have a decimal and a radical, but that's okay. It shouldn't happen in your homework. But if you take half of 5, which is 2.5, and then multiply the outside numbers, 2.5 times 37, you should get 92.5 square roots of 3 feet squared. The ones in your homework should end up with integer answers in front of the radical, but we just want to leave it radical form. Okay, questions on the trapezoids? Okay, the trapezoids are definitely the more challenging part of this section. The kites and rhombuses are much easier to work with. So let's start with the kite. So remember, a kite has 2 sets of congruent sides, 2 sets of adjacent congruent sides. And we're going to have the diagonals of the kite. Okay, so for this kite, that segment, that top segment is going to be 2 inches. The bottom segment is going to be 8 inches. The left segment is 4 inches, and the right segment is 4 inches as well. Okay, to find the area of a kite or a rhombus, you're going to take both diagonals, the entire diagonal, and multiply them together. So let's start with the vertical diagonal. They give me each piece, so what is the entire vertical diagonal? 10, 2 plus 8, times, what's the horizontal diagonal? 8. You have to take half of that. Okay, so half of 10 times 8 would be 40 inches squared. Okay, it also works the same way for a rhombus. So I tend to be a little challenged when it comes to drawing rhombuses. That was really good. You should have seen the one I drew last class because it did not look like that. Okay. Sorry, gotta toot my own horn a little bit sometimes. Okay, so we've got this rhombus. We're gonna have both diagonals of our rhombus. Now, before I give you the dimensions here, rhombuses, and specifically the diagonals of a rhombus, had a lot of really cool properties. Do you guys remember what any of the properties of the diagonals of a rhombus? They bisect each other, which is very handy. So it doesn't mean that the diagonals are congruent, because they definitely are not all of the time, okay? But they bisect each other, so each segment of the diagonals are congruent, okay? Now specifically, what kind of bisectors are they? They are angle bisectors. What about that angle right there? They're perpendicular bisectors. Okay, so lots of cool properties here for the rhombuses. Okay, so let's say for this rhombus, that little chunk right there is 8 centimeters, and then that up there is going to be 5 centimeters. Now, to find the area of a rhombus, you need the entire diagonal. So let's talk about that horizontal diagonal. You tell me that much is 8, so what's the other part? Also 8. So that entire diagonal is 16. Now the vertical diagonal, what's the entire vertical diagonal? 10. Now remember, you have to take half of that. So half of 16 times 10 will give you 80 centimeters squared. Okay, last one. You're going to have one super similar to this in your homework. Okay, so we're going to go back to looking at a rhombus. And for this rhombus, I'm just going to give you one diagonal. And we're going to say that this diagonal is 16 meters. But then I'm also going to tell you that this side here is 10 meters. Okay, so remember, to find the area of a rhombus, I need both diagonals. They do give me that one big diagonal, but I need this diagonal right here. Let's talk about a game plan. What are some of the super fun and interesting things we know about the diagonals of a rhombus? They bisect each other. So I know if the whole thing is 16, that's 8 and that's 8. It doesn't really help me with that one because I don't know what that diagonal is. But what kind of bisectors are they? Perpendicular bisectors. What did I create? Right. Triangle. See where this is going? I need to find this. I can double it, and I've got the whole side. How can I find a missing side of a right triangle? Pythagorean theorem, because it's not a special right triangle, right? But I could do the Pythagorean theorem. So, the sum of the squares of the legs, okay? So we're going to take x squared plus 8 squared equals the square of the hypotenuse. So, not 100 squared, just 10 squared. So we're going to do x squared plus 64 equals 100. Move this 64 over. We'd have x squared equals 36. Take the square root, so x equals 6. Now remember, what that 6 is, it's just that chunk of that diagonal. I need the whole diagonal. What's the whole diagonal? 12. So you're going to take 12 times 16 times 1/2. Okay, and you should get 96. I did that wrong in the last class. I said 72. It is definitely 96 meters squared. Okay, very good.